Good day, students. In this group, we're going to be going over translation of parent functions and also how to state their domain and range using uh, set builder notation. All right, so let's go ahead and write down the instructions for the questions. So using the parent function, uh, find the value of the translated function of the translated function g of x, sketch the graph, and lastly, state the domain and range. Okay, sketch the graph and state the domain and range. The domain and range. Okay. All right. So let's go ahead and take a look at the first question. The first question we're going to look at is a quadratic situation. So for number one, we have g of x is a transformation of f of x given by f of x plus 3 minus 2, where f of x, the parent function, is x squared. Okay? All right, so let's do this one. So first of all, we need to find the value for the translated function g of x, and then we're going to sketch that graph and state the domain and range, okay? So we're going to have f of x plus 3 minus 2, so we're going to compose this function with x minus 3 and then subtract 2 from the resulting answer. So g of x is simply going to be, instead of x squared, is going to be quantity x plus 3 squared minus 2. Okay, so this is f of x plus 3 minus 2. Okay? Alright, so now we're going to sketch the graph, but before we sketch the graph, let's take a look at the shifts to the parent function as a result of this transformation, okay? So what are the shifts? So the number next to the x, you'll basically do the opposite of that. So since it's plus 3, you're going to shift 3 units to the left. And then the number outside, you basically follow that number. This is going to be your vertical shifts. Okay, so this one you just go, now minus 2 means you're going to go 2 units down. All right, so remember the number next to the x, you do the opposite, and the number outside the function that's been added to or subtracted from the function, you just basically follow that. Okay, all right, so let's go ahead and sketch the resulting graph. We're shifting 3 units to the left and 2 units down. That takes us to quadrant 3, so let's shift our axis to compensate for that change. Alright, so basically if we go 3 units to the left, let's label the axis, this is my x-axis and my y-axis. If I go 3 units to the left, I'll go 1, 2, 3, and then 2 units down, 1, 2. This will be my new center, so to speak. Okay, this will be my imaginary new coordinate system. Now I'm going to draw this function on there. This is not a hard function to draw at all, so I don't need to draw my imaginary coordinate system. But for some functions with asymptotes and are slightly complicated, it's beneficial to draw your new coordinate system. But let me just put it in so you can see what it looks like, just to prep you for more complicated problems. So this is our new coordinate system, considering the shifts that we just did. Our coordinate system shifted 3 units to the left and 2 units down, so it's a new coordinate system. So now we're going to draw just sketch a parabola. It's not a perfect curve, it's just a sketch. So sketch the parabola as best as you can. Oh, no, I that. Ooh, that's terrible. Do that again. So going up. All right, so there goes the graph of your parabola. So what we're going to do next is state the domain and range. Okay, so the domain is the horizontal span. Domain is goes from negative infinity to infinity with a set of all real numbers. And then the range, you go as low as 1, 2, as low as 2, and then from 2 all the way to, from negative 2 all the way to infinity. Okay, so how low do you go? You go as low as negative 2. Negative 2 is included in the domain, I mean in the range. and then go as high as infinity. Okay? So that goes the domain and the range of your translated function. Alright, let's move on to question number 2. For question 2, we have g of x, a transformation of f given by f of x minus 2 plus 4. And this is for f of x equals x to the third, your cubic function. Okay? Alright, so let's find out what the transformed function g of x is first, and then we're going to sketch a graph. Okay? So g of x basically is you composing this function x to the third with x minus 2, and then you're going to shift it 4 units up. So that's going to look like, instead of x to the third, it's going to be x minus 2 to the third plus 4. Okay? Alright, let's take a look at the shifts real quick. The number next to the x in the parentheses, you do the opposite. So since it's minus 2, you're going to shift 2 units to the right in the direction of the x-axis because the number is right next to your x. And then you're going to shift 4 units up. The number outside has been added to the function. You just follow that sign, so 4 units up. Okay, so this will take us to our new center, new origin for our transform coordinate system. Okay, so let's go ahead and sketch the original coordinate system. We're going to be, the new center is going to be in quadrant 1, so let's make it sufficiently large. So this is your x-axis, and there goes your y-axis. Okay, now we're going to shift 2 units to the right, 1, 2, 4 units up, 1, 2, 3, 4. Alright, now you know how your cubic curve looks like. Okay, so we're going to sketch it here. It's just a sketch, but let me draw in my new coordinate system. You don't need to do it, but it helps orient your curve. Okay, so draw my new coordinate system for the transform function, and then just put in a sketch of your cubic function like that, and it curves a little bit like this, and it goes down that way. Okay, alright, so there goes your cubic function. Now that we have a sketch, let's state the domain. What is the horizontal span of your graph? It goes from negative infinity to infinity. And then your vertical span, the range, goes from negative infinity to infinity. Okay? So there you have it. Alright, let's shift our attention to question number 3. Now what if we have the transformed function g of x given by negative f of negative x plus 3 plus 2, and this is a transformation of the parent function f of x, which is the parent exponential function e to the x. Okay, alright, so let's do this. First of all, let's find out what g of x is using this parent function. So g of x is basically what you get when you compose this function with negative x plus 3 and shift it 2 units up, and you also have this negativity here, so you have minus e to the negative x plus 3. You replace this x with what it's composed with, which is negative x plus 3 plus 2. Okay? Alright, so in order to know exactly what the translations are along the x-axis and the reflection, the horizontal reflection, we have to write this with the parenthesis around the x. So I'm going to write this as g of x is going to be negative e, factor out that minus, negative x. So since you factor out minus from this plus, it becomes minus 3. Close that, plus 2. Okay? Now in this form, it's easy to determine the translation and also the nature of the reflection. Okay? So this one, our shifts are as follows. We have a negative 3 next to the x, so you do the opposite. So it's 3 units along the x-axis to the right, and plus 2, it's outside. It's being added to the function, so you're going to go 2 units up in that direction. Okay, we have minuses here, so there's going to be, you're going to have reflections. Okay, so let's do address that, the reflections. Since there's a minus in front of the function, that means there is going to be a reflection along the y-axis up and down. And then since there's a minus next to the x here, there's also going to be a side-to-side reflection. Okay, so we're going to have reflected up and down and then side to side. Alright, so let's go ahead and sketch the graph. We're moving 3 units to the right, 2 units up, so our center is going to be in quadrant 1. So let's draw a coordinate system. Y-axis, x-axis. So let's see. We're gonna move 3 units to the right, 1, 2, 3, and you're gonna go up 1, 2. All right, let's go ahead and draw our new coordinate system. Our new coordinate system is right here. My new y-axis and then my new x-axis. Let's label the old one so we don't get confused. This is the original x and this is the original y. Okay. All right. Now, if we shifted the exponential function 3 units to the right and 2 units up, it's going to look something like the typical exponential function, which is something like this, which increases in this orientation. But there are two reflections going on here. It's reflected sideways and downwards. So if it's reflected sideways and downwards, it's going to look like this. So the first reflection, let's do the sideways, the downward reflection first. If we reflect it downwards, it doesn't matter the order we do it. If we reflect it downwards, it's going to look something like this. And then if we reflect it sideways, remember this asymptote right here. If you reflect it sideways, then this side comes here and the other side goes there. So your function is going to look, this piece gets reflected sideways, looks something like this. And then the other piece that goes that way goes like that. Okay, so that's what you have when you shifted 3 units to the right, 2 units up, reflected downwards, and then sideways. All right. Okay, so there goes all the reflections that we need. Remember, this is an asymptote right here. It gets really close to 0 but never crosses it, a horizontal asymptote. Okay, so there you have the function. This is a translated function. Okay, so now we have to state the domain and the range. The domain here for this function is negative infinity to infinity, set of all real numbers. And then the range, how low does the graph go? It goes as low as negative infinity. And how high does it go? It goes as high as this asymptote right here, which is y equals 2, so all the way to 2 and parentheses. Okay, so there goes your domain and your range for the transformed exponential function. All right, let's shift our attention to question number 4. Number 4, what if we have g of x be the transformed function of the form negative natural logarithm of parentheses negative x um, let me just change that real quick. Let g of x be negative f of negative x minus 3 minus 1 when the parent function is parent function f of x is your natural logarithmic function ln x. Okay? Alright, so let's try this one. So if we compose the natural logarithmic function with negative x minus 3, we're going to get the function g of x is going to be negative natural logarithm of negative x minus 3 minus 1. Okay, just replace the x with negative x minus 3. Now, let's rewrite this interior piece, the argument of your logarithmic function, in a way that's easy to determine what the shifts are and also the reflection along the x-axis, okay? So we can rewrite this as g of x equals negative the natural logarithm of factor out the minus x plus 3. Okay, close that, minus 1. Alright, we can clearly see that we have two reflections here, just like the previous problem. And we have vertical and horizontal translations too. So let's address the shifts or the translations first, and then we'll talk about the reflections later. So the shifts, we have a 3 next to the x. So we'll do the opposite of what the sign is telling us. So that means we're going to go 3 units to the left. Minus 1 outside the function means we're just going to subtract 1 from the function, or basically shift 1 unit in that direction of that sign along the y-axis, 1 unit down. Alright? Okay. Now, what we're going to do next is to address the component of the reflection. Now, if you have negative next to the x, that means you're going to have a side-to-side reflection. And then you also have a negative in front of the function. That means you're going to have an up and down reflection also. So we're going to have two reflections in this problem. Okay? Alright, so let's go ahead and sketch the graph. Our coordinate system, we're moving 3 units to the left and 1 unit down. So we're going to end up in quadrant number 3. So let's make sure quadrant 3 is sufficiently large. Alright, so there goes our coordinate system. X and this is Y. Now, our new origin is going to be 3 units to the left and 1 unit down. Alright, let's draw a new coordinate system just to get our orientation together. And it helps create a more accurate sketch. Alright, so now, if we wanted to draw the original natural log function on this new coordinate system, it's going to look something like this. You know what your natural logarithmic function looks like, right? It's going to look something like this, just like a sketch, and you have an asymptote here. So if we reflect it side to side because of this negative sign in front of the x, this is going to get reflected to the side, and it will look something like this. Okay? And then because of this negative in front of the function, we also have to reflect it up or down. So this piece gets reflected upwards, gets close to this asymptote but doesn't touch it, and then this piece gets reflected downwards. So it kind of looks something like this. Okay, let me sketch that again, make it a little bit smoother. So there goes your logarithmic function reflected vertically and horizontally. Okay. Alright, so there goes the function. The green ones are just to help you get your orientation together. Okay, so what's the domain here? What's the domain of your translated function? Your domain is from negative infinity all the way to negative 3. Parentheses because this line is not included. And your range is your vertical span, and it goes from negative infinity all the way to infinity. Alright, so there goes your domain and your range. Alright, let's shift our attention to number 5, question 5. What if we have the transformed function given by g of x equals negative f of x minus 3 plus 2. If the parent function f of x equals the absolute value of x. Okay? Alright, so let's determine what the transformed function is, g of x, by composing this parent function with this expression right here. So g of x is basically going to be negative. So instead of the absolute value of x is going to be absolute value of x minus 3, and that function plus 2. Okay? Alright, so we have shifts here and also a reflection. Let's address the shifts part first. So for the shifts, negative 3 is next to the x, so we're going to do the opposite movement. So that's 3 units to the right shift, and then this positive 2 is being added to the function. You're adding 2 to the function, so that's going to be a 2 units shift upwards. Okay? Alright, and then concerning the reflection, we just have a reflection vertically. Since there's a minus in front of the function, you go in the direction of the y-axis, up and down. Okay, so this is going to be an up and down reflection. Whatever piece of the function is below the y-axis goes up, below the x-axis goes up, and any piece above it goes down. Okay, alright, so let's draw our original coordinate system first. There goes your y, and there goes your x. Alright, now to find our new center, new origin, which can help us construct our new coordinate system, we're going to shift 3 units to the right, 1 to 3, and 2 units up, 1, 2. Alright, now we're going to sketch our new coordinate system. It's not necessary, but it helps to orient our translated curve. Okay? Alright, so there goes the new y and the new x as a result of the translation. Let's label our old coordinate system, x and y. Alright, now you remember what the absolute value function looks like. It's like a V facing up opening upwards, but since there's a reflection downwards, that V gets flipped downwards, okay? The V gets flipped downwards, so it's going to look something like this. There's no dilation here, so it's your basic absolute value curve going down, okay? So this is what the translated function will look like. Alright, so what is the domain of this function? The domain is the horizontal span. It goes from negative infinity to infinity. And what is the range of this function? How low does it go? It goes as low as negative infinity. And how high does it go? It goes as high as positive 2. Okay, so I'll write this again. It goes from negative infinity to positive 2. Positive 2, and 2 is included in the range. All right, it assumes that value. That's okay. So there goes your range. All right, let's try another example. Slightly more complicated. Question 6. What if we have a translated function g of x expressed as negative f of x plus 2 minus 3, when the parent function f of x is equal to the square root of 9 minus x squared. Okay? Alright, this function right here might look unfamiliar, but it is a function for a semicircle that's facing downwards, okay? The upward semicircle. Either a negative, it will be the downward semicircle, okay? Alright, so that's what this is. So we're going to be translating a semicircle with radius 3 using this criteria right here. So let's determine what the composed function is first. So g of x, which is what you get when you compose this function with x plus 2, is going to be negative square root of 9 minus, instead of x squared, is going to be x plus 2 quantity squared minus 3. Okay, so there you have it. Now let's talk about the shifts first, and then we'll address the reflections later. Alright, shifts. Next to the x, you have plus 2, so we're going to do the opposite. 2 units along the x-axis in the opposite direction, 2 units to the left. And this minus 3 means that the whole function is going to be shifted 3 units down. So down 3 units. Let me switch the order for 3 units down. Alright, so that's those are basically the shifts for this function. Alright, but we have one reflection because the whole function is negated here. So reflection. Since the whole function is negated, that reflection is going to be along the y-axis up and down. Alright? Okay, so one thing you just want to note is that the radius of this function, the radius of this semicircle is the square root of 9, which is 3. Okay? Alright, so let's do this. We're going to draw the graph. Shift 2 units to the left, 3 units down. Let's draw a coordinate system. There goes our y coordinate, and our x coordinate, and there goes the y coordinate. Now let's find our new center. 2 units to the right, 1, 2, and then 3 units down, 1, 2, 3. So that goes your new center right there, okay? Alright, so what we're going to do is we're going to draw a new coordinate system. Something like this. As a result of the translation. Alright, now if we join our semicircle of radius 3, without the reflection, it will open upwards. It will look something like this, from here through here through here. It's going to look something like this semicircle right here. Okay? But there's a reflection up and down. So this semicircle is actually going to open downwards, 1, 2, 3. So it's going to open downwards like this. So this is what the function will look like. Draw a semicircle as best as I can. Like that. Okay, this is supposed to be a semicircle, but this is just a sketch. So you get what I mean. So this is the bottom piece is what the function looks like. Had it been that there were no negatives, it would be the upper semicircle, but we're going to do the bottom part. Alright, so that's basically what your semicircle looks like. Alright, so now we're going to shift our attention to the last question of problem 7. Problem 7, we have the transform function g of x equals f of negative x plus 2, and then the whole function minus 3. And the parent function f of x is your parent rational function 1 over x. Okay? Alright, so let's find out what the value of the transformed function is using the parent function by composing it with negative x plus 2 and shifting it 3 units down. So that's going to give us 1 over, instead of x, is going to be 1 over negative x plus 2 minus 3. Okay? If we simplify it further, so it's easy to determine the reflection, we're going to have g of x be 1 over, factor out that minus, negative x minus 2. Okay, minus 3. Alright, so let's talk about the shifts first, and then we'll do the reflections later. So shifts, you have a negative 2 next to the x, so you do the opposite, so it's going to be 2 units shifted to the right. And then you have negative 3 here, the whole function, you're subtracting 3, so that's going to be a 3 units shift downwards. Okay? And now this negative next to the x means that there's going to be a reflection. Okay? There's going to be a reflection in the direction of the x-axis, so that is going to be side to side. Alright? Okay, now we have all the pieces of information we need to draw this graph. So let's draw our coordinate system first. Our y-axis and x-axis. This function is going to be centered in the 4th quadrant. So let's make it sufficiently large. Okay, now center is 2, 3. So we're going to go 1, 2, and then down 1, 2, 3. Okay? Alright, let's draw our new coordinate system. There goes our new y, and then our new x-axis. Alright, so had it been that we just had translations, our function will look something like this. Let me make it in green. It will look something, remember what your parent's rational function looked like, right? It looks something like this, like that, and then the other piece going in that direction. Okay? But since we have a side-to-side reflection, this piece gets reflected here and the other piece gets reflected there. So our final result is going to look like this. One piece here, and then the other piece gets reflected over there like that. Okay? So there goes your final result. Okay, now domain and range. I think I didn't state the domain and range for this problem. Let's go ahead and do that real quick. The domain for this function, you're going from 1, 2, 3, 4, 5, from negative 5 all the way to 1. And then for your range, you're going as low as 1, 2, 3, 4, 5, 6, from 6 all the way to, actually negative 6, all the way to 1, 2, 3, negative 3. Okay? So sorry about that. There goes the domain and range for that. Now let's shift attention to this one right here. And let's state the domain and range. And that'll be that. Okay? So your domain here is your horizontal span. You go from negative infinity to your vertical asymptote, which is at 2, all the way to 2. And then you're going to jump, and then you go from 2 to infinity. There goes your horizontal span. Okay? Your vertical span, which is your range, you're going to go from negative infinity all the way to your horizontal asymptote right here, which is at 1, 2, 3, negative 3. Union, and then you go from negative 3 all the way to infinity, and that's your range. Okay? So there you have it. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking here, and please post a comment to let me know what you think about this clip. More clips can be found on mathgotserved.com. Thanks again and have a wonderful day.